All right, so we're talking more about slope. We're going to talk about parallel lines first. So parallel lines, or two distinct lines, are parallel if and only if their slopes are equal or their slopes are both undefined. So here they're both equal. You can see that they're just going along the same way. Their slopes are the same. It also says both undefined because their slopes aren't equal. They're actually equal to an undefined slope, and so they're not really equivalent, but they are both going straight up and down. So our first example, we're going to write the equation of a line in point-slope form and slope-intercept form that is passing through this point and parallel to the line whose equation is y equal to 2x plus 1. So this will be example 1. So we're given that the point is -3, 1, and the equation is y is equal to 2x plus 1. So what we need this for is, we're told that it's parallel to that, which means it has the exact same slope. So our m would be equal to 2. Remember, it's just the number, not the number and x, just the number. And then we're going to write the equation of a line. Well, that tells us we're going to use y minus y1 equal to m times x minus x1. So y minus, let's go ahead and label our points there. y1 will be 3. y1 will be 1 equal to our slope of 2 times x minus a -3. Don't forget the negative sign. All right, so y minus 1 equals 2 times x plus 3, because that double negative will make it a plus. This is going to be our point-slope form. And now we need to solve it down for the slope-intercept of y equals mx plus b. So y minus 1 is 2 times x plus 2 times 3, so 2x plus 6. Add 1 to both sides. Y is equal to 2x. 6 plus 1 is 7. And this would be the slope-intercept form. Now, perpendicular lines intersect at a 90-degree angle. Slopes are negative reciprocals. You flip the fraction and the sign. Vertical lines, the m is equal to undefined, and horizontal lines, where the m is equal to 0, are perpendicular to each other. A perpendicular slope example would be if m equals 5. This is the notation for a perpendicular. So a perpendicular slope of m equal to 5, you would flip 5 would be over 1 would become 1 over 5 and flip the sign. M is equal to -3/4. The perpendicular slope of that would be 4/3, flip the sign from negative to positive. All right, our second problem is to write an equation of a line in point-slope form and slope-intercept form passing through 1, 5 and perpendicular to y equals 3x minus 4. So here's example 2. So we're given our point, and our point is 1, 5, and it's y equal to 3x minus 4 that we are perpendicular to. So the first thing we need to do is find the slope of our equation here. Well, this slope is 3, so the perpendicular slope, we're going to remember this would be like 3 over 1, so we'll flip it over. Every whole number is over 1, so it'll be 1/3. This one's positive, this will be negative. So we're back to y minus y1 equals m times x minus x1. Again, label your point. So y minus 5 is equal to -1/3 times x minus 1. So this here is going to be your point slope. Now I don't want to multiply by the 1/3 and then have to add 5 to it later. So what I'm going to do is multiply both sides by that denominator of 3. So that will get me 3 times y is 3y. 3 times -5 is -15. The 3 will cancel on this side, and we have -1 times x minus 1. We're going to take an extra step just so you can see. I just canceled out the 3. So this will now be 3y minus 15 equals negative x. Negative 1 times negative 1 would be positive 1. Now we'll add our 15 over. We get 3y is equal to negative x plus 16, and then divide each part by 3. So y is equal to negative 1/3 x plus 16 over 3. Our next example is example 3. Oh, wait. And this would be our slope-intercept. So write an equation of a function in point-slope form and slope-intercept form passing through 3, 5 and perpendicular to x equals 10. Well, x equals 10, we have to remember what our slope is for that. So let's go to example 3. So example 3, we are given our point of 3, 5, and we're looking at x equals 10. When we're looking at an x equals 10, that tells us it's a vertical line. And what is the slope of a vertical line? Well, our slope would be undefined. And we are told in our problem that we're looking for the slope that's perpendicular to that. So our perpendicular slope would be equal to 0. So now we're back to y minus y1 is equal to m times x minus x1 and y1. So y minus 5 is equal to 0 times x minus 3. Well, on this side here, everything becomes 0 because anything times 0 is 0. So y minus 5 is 0. We'll add the 5 over, and we get y is equal to 5. Now we could also see that with this perpendicular, if this is x equals 10, if we're looking for the perpendicular line, we know it's going to be a horizontal line, which would be y equals to 5. So if you need to show your work, you would go this way. But if you're working a homework problem, understand, if you do understand, you can take the shortcut here, that if I know this is a vertical, my perpendicular will be a horizontal, and it's always going to be the y equals part. All right, let's look at, also, just to let you know, remember that this f of x is the same thing as y. This is just called function notation, which you might start to see. So the next thing we're going to look at is slope as a rate of change. If we draw a line between 2 points, we get an average rate of change between the 2 points. We call this line a secant line. So here we can see the secant line's going, and we've got our 2 points here. What we really need to know is the average rate of change of a function is this. So here's our regular slope formula that we know, so it's just like it. Remember that y sub 2 is the same thing as f of x sub 2, because y is the same thing as f of x, but because we have that subnotation, it's going to take on the 2, and this one will take on the 1. So we'll have f of x sub 2 minus f of x sub 1 still over the x sub 2 minus x sub 1. So we're going to find the average rate of change of f of x equals x squared from a couple of different points. All right, so let's go to example 4. And we are looking that f of x is equal to x squared. For part A, we're looking at x sub 1 equals 0 to x sub 2 equals 1. I'll write the formula down. We're looking at f of x sub 2 minus f at x sub 1 all over x sub 2 minus x sub 1. So what this will look like for us is f of x sub 2 is 1, so f at 1 minus x sub 1 is 0, so f at 0, all over 1 minus 0. So the 1s and the 0s should be right on top of each other there. Now you can work these as you get into more complicated ones. We'll work them a little bit separately, but this is a pretty simple problem with it just being x squared. So 1, plugging 1 in, x squared, that would be 1 squared. So we're going to just write it as 1 squared minus 0 squared all over 1 minus 0 is 1. Well, 1 squared is 1. Minus 0 squared, well, that's just minus 0 over 1. This will just be 1 over 1, which is 1. All right, let's look at part B. Part B says our x sub 1 is equal to 1, and our x sub 2 is equal to 2. So we're going to do the same process, except this time instead of f at 1, because we need to use our x sub 2, it'll be f at 2 minus our f of x sub 1, which is 1, all over 2 minus 1. So 2 going into our x squared will be 2 squared minus 1 squared. 2 minus 1 will still get us 1. 2 squared is 4 minus 1 squared is 1 all over 1. I don't really need to write the 1 because all over 1 is not going to change anything. 4 minus 1 will get us 3. So that would be your answer there. All right, let's look at the last one. So we have x sub 1 equals negative 2 to x sub 2 equals 0. So we'll have f at 0 minus f at negative 2 all over 0 minus a negative 2. So this will be 0 squared minus negative 2 squared, and this will become 0 plus 2. So 0 squared is 0 minus negative 2 squared is actually positive 4, and 0 plus 2 is 2. So it's negative 4 over 2, which would become negative 2. All right, example 5. We're going to find the average rate of change of f of x equals x squared plus 5x from x sub 1 equals 4 to x sub 2 equals 5. So we have f of x equals x squared plus 5x, looking for x sub 1 equals 4 to x sub 2 equals 5. Remember, it's f of x sub 2 minus f of x sub 1 over x sub 2 minus x sub 1. The more you write those formulas, the more you will know them. All right, so this will be f at 5 minus f at 4 over 5 minus 4. Now this one's a little more complicated in the math, so I'm going to go find f at 5 and find f at 4. So I'm going to step away from my equation, step down here and find f at 5. So that'll be 5 squared minus 5 times 5. That's 25. Oh, sorry, this should be plus. X squared plus 5x. So 5 times 5 will be again 25, which will get us 50. And then f at 4 will be 4 squared plus 5 times 4. 4 squared is 16. 5 times 4 is 20, which will get us 36. So now we can take those numbers and come back up here. So f at 5 was equal to 50 minus f at 4 is 36. 5 minus 4 is 1. 50 minus 36 will get us 14. And that would be your answer. All right, example 6, we're going to find the average rate of change for our function is f of x is equal to the square root of x, where x sub 1 is equal to 49 and x sub 2 is equal to 64. So again, we have f of x sub 2 minus f of x sub 1 all over x sub 2 minus x sub 1. So we'll have f at 64 minus f at 49 all over 64 minus 49. This one again is a simple one, so we can just plug it in. 64 goes in, we have the square root of 64 minus the square root of 49. 64 minus 49 will get us 15. Well, the square root of 64 is 8, minus the square root of 49 is 7, all over 15. 8 minus 7 will get us 1 over 15, and that'll be our final answer. All right, example 7. Find a linear function in slope-intercept form. It should model the percentage of total spending, P of x, by Americans X years after 1950. So in 1950, Americans spent 22% of their budget on food. This has decreased at an average rate of approximately 0.25 per year since then. So we're looking at creating the formula. Remember, so this will be example 7. We're looking for y is equal to mx plus b, because we're looking for a function, a linear function, and it said slope-intercept form. But our function will be called p of x. So it'll look like this. Now our rate of change, remember, is our m, the rate of change, and they told us that the rate of change was 0.25. And b is going to be the y-intercept. And remember, that's when x is equal to 0. So we're looking at our y-intercept being the number of years after 1950. We're looking at, yes, so x is the number of years after 1950. But we're referring to those years, and they told us that it was 22%. So 22% will be the interest, or the intercept at that point. And then we'll plug in x for how many years that we're looking for. So the y-intercept will be equal to that 22%, which will be just 22. Because when we're looking at the y-intercept, our x is 0, so we're looking at 0 years after 1950, so it's the 22 part. Alrighty, so now we've got our two parts, we can plug it in. So p of x is equal to our m, which is 0.25 times x plus 22. And then we can look at however many years after that, because it's 22%, and that's, or started at 22, and it's going up 0.25% each time. So you can plug in any number of years to see kind of what their budget was on food. All right, example 8. The function f of x is equal to 1.1x cubed minus 35x squared plus 264x plus 557. Models the number of students who dropped out of high school after 1994. Find the slope of the secant line from x sub 1 to x sub 2. And then we're going to find the average rate of change, whether or not it actually goes with it. So, looking at number, example 8, I think we'll probably need another sheet. So example 8, let's write down that big formula. We have f of x is equal to 1.1 x cubed minus 35x squared plus 264x plus 557. It models the number of students who dropped out of high school after 1994. And we are looking for part A, the rate of change, x sub 1 equals 0 to x sub 2 equals 4. So we're looking for that rate of change. So what we need to do is plug in the values. So remember, we are then looking at f at 4 minus f at 0 all over 4 minus 0. Well, the bottom part will be easy. It's going to be 4. But the top part, we have to plug into all of these. So what we're going to do is come down here and find f at 4, which will be 1.1 times 4 cubed minus 35 times 4 squared plus 264 times 4 plus 557. We can plug this into a calculator, and we will actually get 1123.4. And then we're going to find f at 0. So 1.1 times 0 cubed minus 35 times 0 squared plus 264 times 0 plus 557 will equal that 557. So we are looking at our two numbers here will be 1123.4 minus 557. So that will get us 566.4 divided by 4, which will get us about 141.6. We're looking for people, students, so we're going to round that to a whole number of 142. So that's part A. Part B asks us, and this was finding the slope. We want a whole slope. We don't want to do the partial. So, because I realize this really isn't students, it's a slope. If the average rate of change is actually 137 and not 142, does the slope in Part 8 underestimate or overestimate the average yearly increase, and by how much? But we are actually talking about students because we're talking about the number of students who are dropping out. So even though we're talking about the rate of change, we are talking about students. So 137 is the actual one. What does 142 tell us? Is it an overestimation or an underestimation, and by how much? Well, 142 is greater than 147, so we're going to call it overestimated. And then we are going to, by how much, we will take 142 minus 137, which will get us 5. So by 5 dropouts per year.